Video about MANOVA and ANOVA. In this video we'll talk about further, and first we'll talk about the statistical power of the multivariate test. We'll read. In simple term, for MANOVA, I already talk about MANOVA. What is the MANOVA? Calculating more than one variables, and we call it MANOVA. This is thus multivariate analyzing technique usually researchers do while calculating their data. So let's talk about the statistical power of multivariate test. In simple term, for MANOVA, power is the probability that a statistical test will identify a treatment effect if it actually exists. Power can also be expressed as 1 minus the probability of a type second error or beta B error, that is power 1 minus beta. Statistical power play a critical role in any MANOVA analysis because it is used both in the planning process, that is determining necessary sample size, and as a diagnostic measurement of the result, particularly when non-significant effects are found. The power section first examines the impact on the statistical power and then address issue unique to utilizing power analysis in a MANOVA design. This is a thumb 4 about MANOVA and GLM. GLM, it's a computer based technique. We call it a software where we can analyze MANOVA. Let's talk about selecting the statistical measurement. Number first, the preferred measure is the one that is most immune to violations or the assumption underlying MANOVA and yet maintain the greatest power. Each measure is preferred in different situations. Pillar's criteria or Wilk lambda is the preferred measurement when the basic design consider rational, adequate sample size, no violation and assumption approximately equal cell size are met. Pillar's criteria is considered more robust and should be used if sample size decrease. Equal cell size, a pair or homogeneity of covariance is violated. Royal's GCR is more powerful test statistic if the researcher is confident that all options are strictly met and dependent measures are representative of a single dimension of effect. In a vast majority of situations, all of the statistical measures provide similar conclusions. When faced with conflicting conditions, however, statistical measurement can be selected that meet the situation faced by the researcher. Here we talk about the impact on statistical power. The level of power for four statistical criteria, Roy's GCR, Wilks Lambda, Hotline T2 or Pillai's criteria is based on three considerations: the alpha level, the effect size, the treatment, and the sample size of group. Each of these considerations is controllable in varying degree in a MANOVA design and provide the researcher with a number of options in managing the power in order to achieve the desired level of power in the range of 0.80 or above. Statistical significance level alpha A. Power is inversely related to alpha A level selected. Many researchers assume that significance level is fixed at some level, for example 0.5, but it actually is a judgment by the researcher as to where to place the emphasis of statistical testing. Many times the other two elements affecting power, effect size and sample size, are already specified and data have been collected, thus the alpha level become the primary tool in defining the power of an analyzing. By selecting the alpha level required to denote statistical significance, the researcher is balancing the desire to be strict in what is deemed a significant difference between groups while still not setting the criteria high that difference cannot be found. Increasingly, alpha become more conservative, such as moving from zero point zero 0.05 to zero point 0.01, reduce the chance of accepting differences as significant when they are not really significant. However, doing so decrease power because these more selective in what is considered statistical difference also increase the difficulty in finding a significant difference, decreasing the alpha level required for statistical significance. For example, alpha move from zero point 0.5 to zero point 0.10 is considered many times as being less statistical because the researcher is willing to accept smaller group differences as significant. However, in instance when effect size or sample size are smaller than desired, it may be necessary to be less concerned about accepting these false positive and decrease the alpha level to increase power. One such example is when making multiple comparison to control experimental wide error rate, the alpha level is increased for each separate comparison. However, to make several comparisons and still achieve an overall rate of zero point 0.5, many required strict level, suppose zero point 0.1 or less for each separate comparison, those making it hard to final significance differences, that is lower power. Here the researcher may increase the overall alpha level to allow a more reasonable alpha level for the separate test. MANOVA and GLM. The researcher must always be aware of the implication of adjusting the alpha level because the overriding objective of the analysis is not only avoiding type 1 error but also identifying the treatment effects if they do indeed exist. If the alpha level is set too strengtheningly, then the power may be too low to identify valid result. The researcher should try to maintain an acceptable alpha level with power in the range of 0.80. Effect size. How does the researcher increase power when an alpha level is specified? The primary tool at the researcher disposal is the sample size of the group. Before we assess the role of sample size, however, we need to understand the impact of effect size, which is standardized measure of group differences typically expressed as the differences in group means divided by their standard deviation. The formula leads to several generalizations. As would be expected, all other things equal, larger effect size have power that is are easier to find the smaller effect size. The magnitude of effect size has a direct impact on the power of the statistical test. For any given sample size, the power of statistical test will be higher the larger the effect size. Conversely, if a treatment has a smaller expected effect, that is going to take a much larger sample size to achieve the same power as the treatment with large effect size. Researchers are always hoping to design experiment with large effect size. However, when used with final research, researcher must take what they get and those be aware of possible effect size when planning their research as well as analyzing result. Sample size with the alpha level specified and the effect size identified, the final element affecting power is the sample size. In many instances, this element is the most controllable by the researcher. As discussed before, increased sample size generally reduce sampling error and increase the sensitivity. Power of the test, other factor discussed earlier. Alpha level and effect size also affect power and we draws some generalization for ANOVA and MANOVA design. In analyzing with group size of fewer than 30 members, obtaining desired power level can be quite problematic. If effect size are small, then the researcher may be required to decrease alpha, for example 0.5 to zero point 0.10 to obtain desired power. Increasingly, sample size in each group has noticeable effect until group size of approximately 150 are reached, and the increase in the power shows markedly. Remember that large sample size, for example 400 or large, reduce the sample error component to such a smaller level that most smaller differences are regarded as statistically significant. When the sample size do become large and statistical significance is indicate, the researcher must examine the power and effect size to ensure only statistical significance but practical significance as well. Unique issue with MANOVA: the ability to analyze multiple dependent variables in MANOVA creates additional constraint on the power in a MANOVA analysis. One sources of published tables present power in a number of common situations for which MANOVA is applied. However, we can draw some general conclusion from examining a series of conditions encountered in many research design. Table 3 provide an overview of the sample size needed for various level of analysis complexity. A review of the table leads a several general points. Increase the number of dependent variable required increase sample size to maintain a given level of power. The additional sample size need is more pronounced for the smaller effect size. Here is a MANOVA and GLM. Sample size requirement per group for achieving statistical power of 0.80 in MANOVA. Number of group, number of dependent variable, number of dependent variable, number of dependent variable. Group 3, group 4, group 5. Effect size very large, large, medium and small. 2, 4, 6, 8. And this is the group 4 size and it is a group 5 size. Sources, these are the sources where the table have been taken. For small effect size, the researcher must be prepared to engage in a substantial research effect to achieve acceptable of power. For example, to achieve the suggested power of the 0.80 when assessing the small effect size in a 4-group design. 115 subjects per group are required if 2 dependent measurements are used. The required sample size increased to 185 per group if 8 dependent variables are considered. As we can see, the advantage of utilizing multiple dependent measurements come at a cost in our analysis. As such, the researcher must always balance the use of more dependent measures versus have been parsimony in the dependent variable set of occur not only the interpretation but in the statistical test for grouping differences as well. These are calculating power level. To calculate power for ANOVA analysis, published sources 3 and 24 pages as well as the computer program are now available. The method of computing the power of MANOVA, however, are much more limited. Fortunately, most computer programs provide an assessment of power for the significant test and enable the researcher to determine whether the power should play a role in the interpretation of the result. In terms of published material, for the planning purpose, little exists for MANOVA because many elements of the power of MANOVA analysis. The researcher, however, should utilize the tool available for ANOVA and then make adjustment described to approximate the power of MANOVA design. Using the planning and analyzing. So let's talk about the using power in a planning and analyzing. The estimation of power should be used both in planning and analyzing and assessing the result. In the planning stage, the researcher determined the sample size needed to identify the established effect size. In many instances, the effect size can be estimated from prior research of reasoned judgment and even set of minimum level of practical significance. In each cases, the sample size needed to achieve given level of power with the specified alpha level can be determined. By assessing the power of the test criteria after analyzing is completed, the researcher provide context for interpreting the result, especially if significant differences are not found. The researcher must first determine whether the achieved power is sufficient, 0.80 or above. If not, can the analysis be reformulated to provide more power? A possibility increase some from blocking treatment or covariant analysis that will make the test more efficient by accentuating the effect size. If the power was adequate and statistical significance was not found for a treatment effect, then most likely the effect size for treatment was too small to statistical or practical significance. The effect of dependent variable multicollinearity on power. Up to the point we discuss power from the perspective applicable to both ANOVA and MANOVA. In MANOVA, however, the research must also consider the effect of multicollinearity of the dependent variable on the power of the statistical test. The researcher, whether in the planning or analyzing stage, must consider the strength and direction and the correlation as well as the effect size of the dependent variable. If we classify the variable by their effect size as a strong or weak, then several patterns emerge. The first is correlated variable pair is made up either strong or weak variable, then greatest power is achieved. When the correlation between the variable is highly negative, the results suggested that MANOVA is optimized by adding the depend dependent variable with high negative correlation. For example, rather than including two red- redundant measure of the statistical, the researcher might replace one with correlation means satisfaction and dissatisfaction for the increased power. When the correlation variable pair is a maximum strong weak, the power is maximized. When the correlation is high, either positive or negative. One exception of the journal pattern is finding using the multiple item to increase reliability result in a net gain of power if the items are redundant and positively correlated. Here is the review of the power of MANOVA. One of the most important consideration in a successful MANOVA is statistical power of the analysis. Even though researchers engage experiment have much more control over the element, the effect power they must be sure address the issue of reside the preceding section potential problem. The reduced power below the desired value of 0.80 can be occurred. In field research, the researcher is faced not only with less certain about the effect size in analyzing, but also the lack of control of group size and potentially size that may occur in a sampling process. Those issues in design and executions of field research discussed in stage 2 are critical in a successful analysis as well. There is the MANOVA estimation. This I will discuss for upcoming video.